Greetings. We are Group 5 from Section 4 of Thermodynamics. Today we will be discussing the term quasi-equilibrium. Quasi-equilibrium is a thermodynamic process that happens slowly enough for the system to remain in internal equilibrium. A quasi-equilibrium process is a slow process. As stated before, at every point in the process, the system is very close to being in equilibrium. We can draw a solid line to represent the process, for instance, on a PV diagram. During a very fast process such as the uncontrolled expansion of gas in a system, the condition of a system may be far from being in equilibrium. The process is no longer a quasi-equilibrium process. The state of the system is not well defined at every point in the process. We often use dashed lines to represent such a process.
As an example for the quasi-equilibrium process, I would like to talk about the water flowing from a tank. Water flowing from the bottom of a large tank through a hose and a shower head. In this process, the tank drains slowly. The water flows slowly and nearly steady. There are unbalanced forces causing the water to flow from the tank through the tube and the shower head, but the imbalance is modest and acceleration of the water is very gradual. The pressure at the bottom of the tank decreases as the water level drops, but this occurs slowly. Under most circumstances, it will be reasonable to describe this as a quasi-equilibrium process.
With such tiny driving forces, quasi-equilibrium processes very slowly. A compression process shown here could only be considered to be a quasi-equilibrium process as long as the piston moves slowly enough that the pressure inside the gas remains nearly uniform at all times. If the pressure were not uniform, then some regions of the gas will experience an unbalanced force and they will accelerate. That will indicate that system was not at mechanical equilibrium and the process could not be considered to be a quasi-equilibrium process.
The usage of quasi-equilibrium process. When using quasi-equilibrium process, it will cause the maximum work input into the device and obtained maximum work output from the device. Allows the system to adjust internally so that properties on one part of the system do not change any faster than those other parts. Remains the system infinitesimally close to an equilibrium state at all times.
So the concept of a quasi-equilibrium process allows us to plot such a process on the diagram so that we can analyze such a process mathematically. It is for this reason we have to define such a concept, quasi-equilibrium, and then we assume many processes to be quasi-equilibrium processes so we can analyze them. And later in the reversibility part of the thermodynamics course, we will see this quasi-equilibrium process also has something to do with reversible processes, or the concept of reversibility.